Hello everyone, my name is Amol More and welcome to our channel Solution to Blackbook. Now today we are going to discuss a very interesting question. The question is find the number of solutions of 3 raised to mod x into mod of 2 minus mod x equal to 1. Now remember that the question says that we need to find out the number of solutions. It means you do not need to find out the correct exact solutions, mind you, exact solutions, but we need to find out the number of solutions. I always suggest learners that they should always go for the graph when number of solutions are asked, because that way you understand how many solutions are there and you need not calculate them. There are many other videos which I have made based on number of solutions. The link for them will be provided in the description box, where we calculate the fx and gx and then we determine their graphs, draw them and check their point of intersections. So before we start doing that, let me say that I have to modify this particular function. So basically this function can be rewritten as 3 raised to mod x equal to 1 upon mod of 2 minus mod x. This is your function. Now if you check the left hand side, it is f of x. If you check the right hand side, it is g of x. So basically you need to plot the graph of fx and you need to plot the graph of gx, and the points at which they intersect are the solutions. Simple, right? This is your fx, let us say, and I have a gx like this. Now you see that at two values of x, this one value of x and this other value of x, both of them are having the same value of y, because this is your Cartesian coordinate system. So at this value of x they are having the same value of y, and at this value of x they are having the same value of y. It means those are their number of solutions. So basically after drawing the graph of fx and gx, all you have to check is the number of points at which these graphs intersect each other. So I would recommend you something, that first of all you should watch my play with graph series to master the graph making art. Second, I will provide some video links inside the description so as to watch those videos which involve fx and gx graph making and finding the number of solutions. Okay, so we will start with making the graph. First of all, I will make the graph of fx, then I will make the graph of gx, then I will superimpose them on the same graph, and then you will understand, oh, this is how we understand the number of solutions. So do make sure that you watch this video till the very end to understand the very basic and nitty-gritty details of the graph making and finding the number of solutions. So let us start. Now suppose you have x and y coordinate system made like this. Okay, this is your x and y coordinate system, and first of all the fx is 3 raised to mod x. So in such questions how do we proceed? So that I will tell you. First of all, you draw the graph of fx as 3 raised to x, means there is no mod. Now as we all know, when you put the value of x as infinity, the value of y will be infinity. Why? Because 3 raised to infinity is nothing but infinity. And when you put the value of minus x, x as minus infinity, it will be 1 upon 3 raised to infinity, which is 0. So basically when the value of x is minus infinity, value of y is 0, and when the value of x is infinity, value of y is infinity. And when you put the value of x as 0, so this will be 3 raised to 0 and your y means fx will be 1. So we got the 3 points. See, at minus infinity it is 0, at 0 it is 1, and at infinity it is infinity. It means the values are basically increasing. I will show you with a table x and y. When the value of x is minus infinity, it is 0, when it is 0 it is 1, and when it is infinity it is infinity. Okay, this is how you see that the values of x are increasing and the values of y are also increasing. Okay, and if you want to know it in detail, please go and watch my play with graphs series in a very detailed manner. So basically this function can be drawn something like this. At minus x at minus infinity it is 0, so it is increasing, something like this. At 0 it is 1, so this point is 0 comma 1, and after that it is increasing, something like this. At x is approaching infinity, y is also approaching infinity. Now whenever you are making the graph of fx equal to 3 raised to mod x, understand one thing: mod x is a positive quantity. So even if you put the value of x as negative, what will happen? Mod x will give you the positive answer. It means the negative values of x actually never exist in the graph to give output. Even if you put them, they are going to give you the positive answer. Let me show you. 3 raised to 2 is 9, mod 2 actually, right? But 3 raised to mod of minus 2, what will it be? Again it will be 3 raised to 2 and it will be 9. So 3 raised to mod x graph if you want to make, right, what you need to do is negative side you first rub it, and the positive side answer you reflect that, you draw the same graph to the negative side. It means on the positive side whatever is your graph, same graph will be on your negative side. Now you will say how? See, for 2 we have 9 and for minus 2 also we have 9, right? So this is how you make the graph of 3 raised to mod x, where this intersection is 0 comma 1. So basically we have made the graph of 3 raised to mod x, which was the easier part of the question. Now comes the actual interesting part, which is making the graph of g of x. Now g of x is pretty interesting, as it is 1 upon mod of 2 minus mod of x. Now I have already told you that whenever you are making the graph of mod x, just forget the values of x on the negative side. So what I will do, I will plot the graph of g of x as 1 upon mod of 2 minus x. I will plot the values for x as positive, and the same graph will be copied for negative. But over here there are two mods, so definitely you need to understand graphing in detail. Okay, so let me show you one thing, that over here there is mod to the whole value. It means what? That you need to understand. The first part that you need to understand is that mod means y can never be negative. The whole value is inside the mod, hence the y can never be negative. Okay, so obviously here graphical transformations, I don't know, you are watching the video now, I don't have an idea whether you know graphical transformations or not. So I will not use graphical transformations over here. I will make you understand the basics of it. If you want to learn the graphical transformations, you should follow my playlist, Play with Graphs. Okay, I am again and again telling it because people don't watch, right? I put in a lot of efforts in that series, but not many of the people follow it. So you should actually follow it, then only you will understand how the graphical transformations take place. So over here I will not tell you the graphical transformation, whereas I will tell you the basics. Okay, so let us start. I need to follow 1 upon mod of 2 minus x. I need to plot it. What I am going to do is I will put the values of x and I will get the values of g of x. Now here you should be very careful. As you see, at x equal to 2 the value is not defined, because at x equal to 2 what is going to happen is, I see I am getting the values for this graph. For this graph I am not getting the values because it is mod x. So whatever the answer for positive x, same answer for negative x I am going to copy, right? So negative part I am not even going to bother about. At 2 it is not defined, right? Okay, now let us take a number which is lesser than 2. So first of all I will take 0. So put the value of x as 0. It will be 1 upon 2 minus 0, which will be 1 upon 2. Mod of 2 is 2. 1 upon 2 is 0.5. Very right. Okay, then you put the value of x as 1. Once you put the value of x as 1, it will be 1 only. Then you just move ahead, right? When you move ahead, you get the value of x as 3, let us say. So 1 upon 2 minus 3 will be 1 upon minus 1, but it will be inside mod. So 1 upon mod of 1 will be 1 only. And then you move ahead, you put the value of x as 4. Then again you will get 2 minus 4, which is 2. So 1 upon mod of minus 2, again it will be the same 0.5. Right, now you see there is a transformation, right? Before 2 the values were 1 and 0.5, and after 2 also the values are 1 and 0.5. It means there is some problem just before 2 and just after 2. Exactly, that's what I am going to show you. and it will be very very interesting. Okay, we cannot calculate the value at 2, but I will calculate the value just before 2. Just before 2. Now just before 2, what will happen? X will be very very close to 2, 1.9999999, so on, right? So 1 upon 2 minus mod x if you do. So 2 minus 1.9999 so on, it will be 0.000001, and then you will have a mod. So inside the denominator you have a very small number, so that will practically approximately will you give you the answer infinity, right? Because 1 is divided by a very small number, so it is going to give you the answer infinity. Just remember this, 1 is divided by 2, it gives you 0.5. 1 is divided by 0.2, right, it gives you 5. 1 is divided by 0.02, it gives you 50. See, as I am decreasing the denominator, the actual answer is increasing, and over here the denominator is actually very small, hence the answer will tend to infinity. And actually the same thing is going to follow when x is equal to 2.000000001, because it will be the same thing in the denominator, because there is mod. If you do 2 minus 2.0000001, it will be minus 0.00001, but because of mod, again it will be the same thing. Just I am putting the zeros, just do not calculate how many zeros I have put, because approximately what is going to give me is infinity, right? Now you might have gotten the idea that just by value putting, see, I did not use any graphical transformation for that matter, neither did I use any hi-fi techniques for the same. I just put in the values and now I know the graph, because at x equal to 0 it is giving me 0.5, and then it is increasing, because after 0.5 it was 1, it is increasing like hell just at the value 2, right? Just at the value 2, and then after 2 it is falling 1.5, and then it is going to fall. It is going to fall like this, right? And when you put the value of x as infinity, 1 upon mod of 2 minus infinity, so 1 upon infinity, and it will be 0. So when x is infinity, this is actually 0. So this graph goes something like this, and then it falls something like this, right? Because at 3 you are going to get the same value. Okay, so let me show you this graphically by plotting it, so that you have no issues after all with this question, because I want to make it sure that you understand every single detail over here. Okay, I'll show you the values. This is 0, this is 1, this is 2, this is 3, right? I'm only going to show you the nature. Now suppose at x equal to 2, you plot a very thin line, just to make sure that you understand the infinity part right. Okay, so let me just straighten it. Okay, now what is happening at 0? It is 0.5, which is over here. At 1 it was what? Let me check that. At 1 it was 1, so at 1 it will be just 1, and at 2 we don't know it, but it is increasing like this. Okay, now understand, at 3 it was 1, just check that out. At 3 it is 1, so at 3 it is 1, and at 4 just check it out. At 4 what it is? At 4 it is 0.5. Now how beautiful it is, at 4 it will be just 0.5. Then see, after achieving infinity it is falling down like this. I hope you loved this graph, because I love it so much. It's very interesting, right? So it is falling like this, and these two curves are trying to meet each other at infinity. They are trying to meet each other at infinity, and this is the part of graph. But as I told you that I had only calculated for 1 upon 2 minus x, and once I put mod x, what happens? Whatever the negative values are going to give me the answer, same values for positive. It means the same graph is going to be copied, right? Same graph I'll have to copy. So let me say over here -2. Okay, I just did some faltugiri. Okay, -2 and -1. I'll put that number line, right? This thin line. Okay, I'll make it correct. Okay, I was never good with drawings. Okay, and the fun fact is I am a civil engineer. Same cheese, we have to copy it down something like this, something like this, something like this, right? Something like this. And then it is going to fall down something like this, something like this, something like this, right? See how interesting it is. And just note this point to be 0.5, 0 comma 0.5, right? Okay, now this is your graph gx, and your gx is nothing but 1 upon mod of 2 minus mod x. See how pretty that graph is, right? Okay, now I am going to do one thing. I am going to draw this on another graph paper. Okay, so let me start. Let me say this is my x-axis and this is my y-axis. Okay, I hope they are straight. Okay, let me make it straight. Very nice. Okay, now I need to understand that 0 comma 0.5 is over here, and my graph is going to go something like this. At 2 it is gonna reach infinity, then it is going to come down something like this. Okay, something like this. Okay, I'm taking a lot of efforts. Okay, if you like this video and the concept that I'm teaching, please subscribe to our channel, and also make sure to like our video and share it with your friends, because see, maths has to be appreciated. Math has to be appreciated, and especially the graphical and very basic solutions are to be appreciated. Okay, now over here I'm going to show you a very thin line. They are not meeting, right? Because at infinity they will meet, and at infinity nobody can reach. Okay, so this particular point is 0 comma 0.5. so this is my gx. This particular part which I have shown is my gx. Now I need to plot fx on the same part. Okay, so what is my fx? My fx was very simple, 3 raised to mod x, and that was just like this. Very simple. Okay, so it will start from 0 comma 1. Okay, so 0 comma 1 is going to go somewhere over here, and I will use a different color for it. Let me say blue color. I like blue color. It is going to go like this. Up to infinity it has to go, right? So up to infinity it will go something like this. Okay, so this particular part which you can see over here in blue is fx. Now you have to just check out how many times fx and gx intersect each other. Okay, now if some people have problem that this 3 raised to mod x will go in between these two lines, then it is not possible, because there is no space at all, because they are going till infinity to reach each other. Okay, so there is no space between them. 3 raised to mod x is gonna go like this only, right? Because that is coming especially right away from the infinity, from the what you can say infinity. Okay, now just check out how many points they are intersecting each other. So let me use a purple pen. This is 1 point, this is 2 point, this is 3 point, and this is 4 point. So basically this was our 3 raised to mod x, and this was our 1 upon mod of 2 minus mod x, and this is how we plotted the graphs, and they are intersecting at 4 different points. We need not know what are those points, but we got them. What were those points? 1 point is before 2, 1 point is after 2, 1 point is before minus 2, and 1 point is lesser than minus 2. So this is how we got the number of solutions to be how much? We got the number of solutions to be 4. So the correct answer to this beautifully formed question is 4. There are 4 different solutions possible. If you liked this video, please make sure to hit the like button. Okay, if I see 100 views on this video, I need 100 likes only. Okay, nobody should live without liking this video. And if you haven't subscribed yet, please subscribe the channel Solution to Black Book, which will be soon called as Solutions by Amol More. आज के लिए बस इतना ही. If you liked this video, please keep coming back, and this is Amol More saying bye bye to you. मिलते हैं next time.